Okay. To sheet 10, question 1. Question 1. Consider the vectors u is equal to -1, 5. V is equal to 2.7, 3.8. W is equal to 4.2, -6. Find the coordinates of the vectors A, U plus V. This is the same as U plus V, which is the same as -1 plus 2.7, 5 plus 3.8. And this is equal to 1.7, 8.8. Those are the coordinates. So you add each component to the corresponding component. Then 3u minus 2v minus 5w. This is 3 -1, 5 minus 2, 2.7, 3.8 minus 5, 4.2, -6. This is, you take inside, you get -3, 15 minus 2.7 by 2. Let me have a calc. 2.7 by 2, 5.4. So 5.4, and then 3.8 by 2, 7.6 minus 4.2 by 2 by 5, 21. That this is equal to -3 minus 5.4 minus 21, 15 minus 7.6 minus 30, giving us -3 minus 5.4 minus 21, that is -29.4, and then 15 minus 7.6 minus 30, -22.6. And then C, U plus V plus W, giving us, now we add direct, -1 plus 2.7, that is -1.7 plus 4.7 plus 4.2, so -1 plus 2.7 plus 4.2, we get 5.9. 5.9, then 5 plus 3.8 minus 6, giving us 2.8. Since we have shown the calculations there, any question for question 1? We are moving to question 2. Okay. Question 2. Question 2a. Find the scalar product of vectors find the scalar product of vectors of vectors A is equal to -3, -1. B is equal to 4, -2. The scalar product is a dot product, which is -3, -1, 4, -2. This is -12. It's a scalar. So -12 plus 2, which is -10. So you multiply dot product, this guy times this guy, plus this guy times the other guy there. B M is equal to -1, 1. N is equal to 1, -1. Then M dot N is -1, 1. Dot 1, -1. -1 minus 1. So it's a scalar. -1 times 1, you get -1. 1 times -1 get -1, giving us -2. And then C, P is equal to √2, √6. And Q is equal to √6, -2. So you say P dot Q is equal to √2, √6 dot √6, -2. So that √2 times √6 we get √12. And then √6 times -2 you get -2. So that's what we get from there. Not complicated. Question.
Sir,
Hello.
this for my root. Here we are going to ignore the root. So here we just multiply the things that are inside. The root, we just be ignoring them.
From SADS, if you have A by B, it's the same as you have A, you have this. So the reverse, if I have this, the same as I have C times D.
Okay, thank you.
Okay. All right. Question 3. Question 3. Find out whether the given vectors are perpendicular to each other. Find out. Whether the following vectors perpendicular to each other. Remember what we said? We said that two vectors are perpendicular Two vectors u and v perpendicular if their dot product is equal to 0. So A, we are given that A is equal to -5,8. B is equal to 2.1, 2.5. So we do the A dot B, we get -5,8 dot 2.1, 2.5. So we have -10.1, -10.1 plus 8 times 2.5, 20 plus 20, giving us positive 9.9. The 9.9. But this is not 0. So A and B are not perpendicular. To each other. B E is equal to half, √3. F is equal to 6, -√3. We check. So do E dot F, which is half √3 dot 6 -√3. This is giving us 3 minus 3, which is 0. Hence, E and F are perpendicular vectors. C, P is equal to √2/2, -√2/2. Q is equal to, R. R is equal to -√3/2, √3/2 . This is going to be, when we do P dot Q, we'll be doing √2/2, -√2/2 dot -√3/2, -√3/2, which is equal to √6 √6/4 plus √6/4, which is equal to 0. Hence, P and R are perpendicular vectors. Any questions this far? So when you see this word here, always know that we're talking about u dot v is equal to 0. Question 4. Question 4. A, find the vector u that is perpendicular to the vector v is equal to 3, 4, and the size of which is 15. This question is asking us to find a vector u that is orthogonal to v. So that means that we are looking for the vector u that when multiplied by v, you get 0. And of size 15, size is the magnitude. Magnitude of u should be equal to 15. So suppose since the v is of 2 coordinates, then suppose that let u be equal to a, b. Then we'll have ab dot 3, 4 equal to 0. So when you multiply here, you get 3a plus 4b is equal to 0. And the modulus of u is the modulus of this guy. This magnitude is the same as the square root of a squared plus b squared. But since we are told that the square root of this guy, as you can see from top here, should be 15. So then we have 2 equations to solve. If from equation 1, we call this 1 and this 2. If from 1, we have a is equal to negative 4b over 3, we solve for a. Then in equation 2, we square, we'll get that a squared plus b squared is equal to 15 squared, 15 by 15, 225. Then where there is a, we substitute negative 4b over 3 must be squared plus b squared is 225. So we'll have 16b squared over 9 plus b squared over 1 is 225. That is, if we multiply throughout by 9, we'll get 16b squared plus 9b squared is equal to 225 times 9, we get 2025. You add this, we'll get 25b squared is equal to 2025. Divide by 25, divide by 25. We'll get b squared is equal to b squared divided by 25 is equal to 81. And so the square root of this guy, So the square root of b squared is equal to the square root of 81. So b is equal to 9, or b is equal to -9. For that reason, we go back and get a now. When b is 9, a is going to be -4 multiplied by 9 over 3. But 3 can go in 9 3 times. So we get -12. And a is -4 -9 over 3, which is equal to -4 -4, oh, -3. -4 -3, giving us +12. Therefore, u is equal to -12, 9, or u is equal to -9, 12. These are the two vectors that gives us that are orthogonal perpendicular to V and have distance 15. Let's check if a distance is 15. What's the modulus of u? It will be a square root of 12 squared, -12 squared plus 9 squared for the first one, giving us where's my calculator? 12 by 12, 144. 144 plus 81, 225. The square root of 225 is 15. So we have proved necessary only for us to see, not for the examiner though.
So I've got a question.
Okay.
Like here where we found the values of A, the other one was -12, the other one was +12. And then here where we're writing U is equals to -12,9. And then on this other one, we swap them. I thought it's supposed to be in order, like 12,9.
Yeah, you're thinking very correct. That's dozen. Yeah. Okay. Then we go to B of the same question. B, prove that the triangle ABC is right angled, given that A is equal to okay, these are points. Given that A 16 1 -2, B -9 1 -12, C 0 1 10. The question is prove that A B C is a right angled triangle. Okay, so if we are to draw something like this, Suppose we put A here, 16, 1, -2. Suppose we put -9, 1, -2. Suppose we put 0, 1, 10. So A, B, C. Prove that this triangle is right angle triangle. You need to find the vectors here. Say this vector U, find the vector V, find the vector W. And check that the magnitude of vector U plus vector V is giving us vector W. Okay. So let's get the vectors and then get their magnitudes. Then it will direct us what to have as a triangle. Since these angles here are not known, so let's see. So we get AB as a vector. We will be saying -9 minus 16, 1 minus 1, -2 minus -2. This is giving us -25, 0, 0. Then we get AC. AC is 0 minus 16, 1 minus 1, 10 minus -2. That is -16, 0, 12. Then we get BC. That is 0 minus -9, 1 minus 1, -2 minus 10, giving us 9, 0, -12. Now let's get the absolute value of AB, the magnitude of AB. That's the square root of -25 squared, since other coordinates are zeros. So we'll get 25. And then AC, 16 squared plus 12 squared. What is 16 squared? 16 by 16 is 256 plus 144. We get 400. The square root of 400 is 20. Okay. Then we get the modulus. We get the magnitude of BC. That is 9 squared plus 12 squared. The negatives is okay because we'll be squaring them, so you must not worry about them. That will be 9 squared, that is 81. 81 plus 144, 225. The square root of 225 is 15. So if this triangle is a right angle triangle, we must have that. We must have that. Suppose this is P, this is Q, and this is R. We must have that. We must have a relationship of saying P squared should be equal to Q squared plus R squared, or any of the combinations. So let's try. Can we say 25 squared is equal to 20 squared plus 15 squared? Let's see. 25 squared is 625. And then 20 squared plus 15 squared is also 625. So then this is true. So the triangle ABC is right triangle. I mean, is right is right angled. And the right angle is between? Yes. So the video will be catching. Also the zoom. So you can even identify which angle now has a 90. A, B plus B, C. Okay. Then so the 90 is between Q and R. Okay, all right. I will. All right. So it's supposed to be like this now. A, B, C. 90 there. Okay, so to cut, we rejoin. It's,